In this video, I've got myself an eyedropper, a penny, 5 pesos, and water, and some tissue. So my goal for this video is to understand cohesion, adhesion, and lastly surface tension. All these three are connected and I will explain them along the way as I try my experiment on this penny. As I pour water using this eyedropper. I'm gonna be counting how many times I can pop it before the water breaks. Yeah, 1, 2, 9, 60. Still, it's not falling. I'm gonna give you a closer look. We're at 60 right now with 60 droplets of water. It's right there, it's 60 droplets of water. It might not look much. Okay, let me see. A bit light there. It's wet. Just trust me, there's 60 droplets of water there. I'm gonna be explaining later how that happens. We're gonna continue counting how many droplets we can go for until the water breaks and why it breaks. We're gonna continue. We're at 60, 61, 62, 63, 64. 63 is the limit. It has broken. What has broken? What has broken is the surface tension. There's far too many water at the top of the penny. That is because of the surface tension. Normal water has a strong surface tension. This is because of the cohesion. And cohesion is the bonding of similar substances. Editor Vaughn here. In the future, I keep saying substances, but what I actually mean here is molecules. Similar molecules attract each other, which creates cohesion. Which in this case, it's water. So they're bonding together, they're being together. Cohesion, they're being together here. And adhesion is them sticking up top the penny, because adhesion is the bonding of two not similar objects. This is just water sticking to the penny, but it's not as strong as water bonding with water. As you can see right now, it has still not broken because it has strong cohesion. The water is sticking, and there's also some adhesion from the penny and the water. So it's not as strong as cohesion, as you know. It's hard to separate water right now since they're together. You can hardly separate water, but you can easily separate the penny and the water, but you cannot. It's very hard to separate water itself, because once they're together it will be pretty hard to separate them. So we have another test to see surface tension. What's gonna happen if we mix soap with the water? Is it gonna be around 63 as well? Will it also be 63 drops of water before the surface tension breaks and the penny cannot handle it anymore? The water could not stick. We're gonna be testing it. We're gonna be adding soap. Here is our soapy water. Soapy water. We're gonna add some soap there. There we go, we have soapy water. We're gonna set up our penny again. Here it is. Our penny. There we go. Get our our drops of water. We're gonna start counting again how much we can do. 1, 2, 3. See, there's already some breaking here. 2, 1, 2, 3. Yep, it's around 30. It's around half. It's just half of normal water. I wonder why. You might also be wondering why soapy water only has around 30. Okay, it has around 30 because soap water actually breaks down the cohesion of the water, the bonding of the water. It makes it weak. That's why it doesn't hold themselves as strong as normal water would. So if you put soapy water, compare it to normal water, it will have less surface tension because the bonding of the water is weaker, because soap just breaks apart this cohesion. And of course, this will also break apart its adhesion because it's not as strongly bonded together already by the same substance. And that's pretty much it. Surface tension and cohesion is uh, connected to each other, because you need strong cohesion for better surface tension, and adhesion is just when something of different substance is also something on a different substance. As I've said, water with the metal and any substance that cannot mix. So that's pretty much it for me. I hope you learned something about cohesion, adhesion, and surface tension of water. Johnny!